In this video, we're going to look at several examples for solving trigonometric equations, and some of these examples are going to involve the use of our identities. We're starting with number 2. They're in lesson 22.2. And for these first 3 examples, we're solving for theta on the interval 0 to 360. So this means I want to find all of the solutions to the equation that are between 0 degrees and 360 degrees. In this first example, I'm going to start by getting that trig function by itself. I'm going to divide by the square root of 3. And so tangent theta is equal to 1 over the square root of 3. And I'm going to rationalize the denominator, get that radical out of the denominator. And so we get tangent theta is equal to square root of 3 over 3. And this is a unit circle value for tangent. You could find these answers on your chart if you're not sure where it happens. Tangent is positive in quadrants 1 and 3. So I'm going to have 2 answers here, one from each of those quadrants. Tangent theta is equal to square root of 3 over 3 at the 30-degree angle. So theta is going to be equal to 30 degrees. That's my quadrant 1 answer. And then the 30-degree angle that's in quadrant 3 is 210 degrees. Let's look at our next example. Here, 2 cosine theta plus the square root of 3 equals 0. I'm going to start out by getting that cosine theta by itself. We're going to subtract square root of 3 from both sides. 2 cosine theta equals negative square root of 3. And then I'm going to divide by 2. And cosine theta equals negative square root of 3 over 2. First, let's think about where cosine is negative. That happens in quadrants 2 and 3. Cosine is equal to the square root of 3 over 2 at the 30-degree angle. And so theta is going to be equal to the 30-degree angle that's in quadrant 2 would be 150 degrees. And the 30-degree angle that's in quadrant 3 is 210. Let's look at this last example. Sine theta minus 3 equals 0. I'm going to add 3 to the other side. Sine theta equals 3. Now, hopefully at this point, maybe you're a little perplexed. 3 is not one of our unit circle values. And in fact, sine theta cannot be equal to 3. If you recall, the range for sine theta is between negative 1 and 1. And so sine theta does not go as high as 3 without some kind of amplitude change or a vertical shift. And so this cannot be equal. And for this particular equation, we have no solutions. All right, let's move on to question number 3. In these equations, we're going to use some factoring to solve. Remember that whenever you're having trouble factoring with the trig functions, you can always change it to a variable. Like I'm going to let sine x be equal to a, and I could rewrite my equation as 4a squared minus 1 equals 0. And you could work with that equation, solve that for a, and then replace a with sine x and figure out your final solutions. I'm going to go ahead and work it with the trig function though. 4 sine squared x minus 1 equals 0. I notice here that I have a difference of squares. 4 sine squared is the square value and 1 is a square number. So we can factor this like a difference of squares. It's going to be 2 sine x and 2 sine x plus 1 minus 1. So then I'm going to set each of those equal to 0. And solve this first one first. 2 sine x equals negative 1. I'm going to divide by 2. Sine x equals negative 1/2. And then my other equation, I if I add 1 to the other side, 2 sine x equals 1, and then divide by 2, and sine x equals 1/2. So for this example, I'm looking for all the places where sine is equal to 1/2 or negative 1/2. And that means we're going to have 4 answers, 4 solutions to this equation. Notice the interval that we were given. We want to find all solutions between 0 and 2 pi. So we are working in radians. X is going to be equal to, my angle is going to be equal to negative 1/2. That's going to be in the quadrants 3 and 4. Sine is equal to 1/2 at the pi over 6 angle. So for the negative 1/2, quadrants 3 and 4, we would have 7 pi over 6 and 11 pi over 6. And for our other equation, that would be in quadrants 1 and 2, pi over 6, and 5 pi over 6. So those are our 4 solutions to this example. All right, next up, 2 tangent squared theta minus tangent theta minus 3 equals 0. And we have an interval 0 to 360. So once again, you could replace tangent theta with a variable and solve it, factor it that way. I'm going to go ahead and work with the trig functions. The numbers that multiply together to give me 2 tangent squared would be 2 tangent theta times 1 tangent theta. That's the only way that I can get 2 is 2 times 1. Numbers that multiply to give me 3 would be 3 and 1. And then I want to get that negative tangent theta in the middle. So if I look at my 2 products that would give me my middle term, here I have 2 tangent theta. This is going to give me 3 tangent theta. So I want negative 3 tangent theta and positive 2 tangent theta. And this is still equal to 0. 2 tangent theta minus 3 equals 0. Tangent theta plus 1 equals 0. I'm going to solve this first equation. 2 tangent theta equals 3. Divide by 2. Tangent theta equals 3/2. Now, 3/2 is not a unit circle value, and so at this point we need to go to our calculator and make sure you're in degree mode. Do inverse tangent of 3/2, and if we do that, we're going to get theta is equal to 56.310 degrees. And so that's one of our solutions here, but remember each of these typically yield 2 solutions. And so if I think about tangent, it's positive in quadrants 1 and 3. And I've got my quadrant 1 angle. I need to also find that quadrant 3 angle. So I'm going to draw a little diagram over here just to help us picture this. Here's my answer that I found already. This angle right here is 56.310. I want to get the same angle down into quadrant 3. And so the way that we're going to find that is 180 plus the 56.310 degrees. And that, of course, would be equal to 236.310 degrees. All right, so there's our 2 solutions for the first factor. I also have tangent theta plus 1 equals 0. So tangent theta equals negative 1 if I subtract 1 to the other side. Now this is a unit circle value. Tangent theta is equal to 1 at the 45 degree angles. It is tangent's negative in quadrants 2 and 4. So I'm looking for those 45 degree angles in quadrants 2 and 4. So that's going to be 135 degrees. That's our quadrant 2 angle. And then the quadrant 4 angle is 315 degrees. All right, question C, sine squared x equals 2 sine x. And we've got an interesting change here, notice that our interval for our solutions this time is negative pi to pi. So it's a different interval. We're going to have to think about our final solutions a little bit differently. But first, let's go ahead and solve this. I notice that we have a squared here. And typically when you're solving an equation and you have a quadratic, we need to factor. And if we're going to factor, we have to get one side equal to 0. So I'm going to subtract this 2 sine x over to the other side. And we have sine squared x minus 2 sine x equal to 0. Now I have two terms here, and typically if we're factoring two terms, we look for a difference of squares. And my first term is the square term, but the second one is not. And so if I can't factor with a difference of squares, then I need to look for a greatest common factor to factor out. And in this case, that would be sine x. Both of my terms have sine x. So I'm going to factor that out, and I'm left with sine x minus 2 equals 0. Now I'm going to set each factor equal to 0. So sine x equals 0, or sine x minus 2 equals 0. And this first one, so we're thinking, where does sine x equal 0? Well, that happens at 0. It also happens at pi, because this is going to be the angles that are on the x-axis. That's where sine, the y-coordinate, would be equal to 0. But remember that my interval for answers goes to negative pi. And so if it's if my solutions are 0 and pi, normally we might think the next solution would be 2 pi, but we really need to go in the negative direction from 0. And so my other solution would be negative pi. For sine x minus 2, if I add 2 to the other side, sine x is equal to 2. And again, we've got an equation here where the resulting value is outside of the range for sine x. Remember, sine only goes from negative 1 to 1. This cannot equal 2. And so for this factor, we have no solutions. And so our only answers are the 0, pi, and negative pi. Now, example D here presents us with a new feature that we might see sometimes in trig equations. Notice here I have two different trig functions, cosine theta and sine theta, in the same equation. And really, if we're solving equations, we need to have just one trig function if at all possible. But in this case, there's no identities that I can use to get rid of one of these trig functions and make it turn into the other trig function. And so we've got to work with what we have here. But factoring is going to help us kind of separate these trig functions into different factors. Notice here I've got two terms, and both terms have a cosine theta. So we're going to factor that out. Cosine theta times 1 minus, and I would be left with 2 sine theta, and that second term equals 0. Now, when I set each of these factors equal to 0, cosine theta equals 0, or 1 minus 2 sine theta equals 0. Now my cosine theta and sine theta, they're in separate equations, and so we can solve. Cosine theta is equal to 0. Remember, cosine is the x-coordinate. That's going to be equal to 0 on the y-axis. And let me take a moment and just acknowledge my interval here is only from 0 degrees to 180 degrees. We're not using the whole circle, only 0 to 180. And so in that interval, cosine theta is going to be equal to 0 at 90 degrees. Now this other example, we need to solve for sine theta, so I'm going to subtract 1 to both sides. Negative 2 sine theta equals negative 1. Divide by negative 2. And sine theta is equal to positive 1/2, because a negative divided by a negative would be positive. Now sine is positive in quadrants 1 and 2, and both of those quadrants are included in our range of 0 to 180 degrees. So for this one, we are going to have two answers. Sine theta is equal to 1/2 at the 30-degree angle. So that's our quadrant 1 angle. And then the 30-degree angle that's in quadrant 2 is 150 degrees. And so for that particular equation, we had 3 separate solutions. All right, number 4. This is going to be our last example for the video. And here, again, we've got cosine and sine in the same equation. I'm going to rewrite this down here where we can see it a little better. And this time, factoring out a cosine or a sine to get them separated is not going to work because not every term has one of those trig functions. In this case, we're going to have to use one of our identities. Remember, we have the identity, the Pythagorean identity, that sine squared theta plus cosine squared theta equals 1. If I solve that for cosine squared theta, it's equal to 1 minus sine squared theta. And so I can use that version of the identity to replace cosine squared theta with 1 minus sine squared theta. And then over here on the right side, we're just going to keep it 1 minus sine theta. So now I have everything in terms of sine theta, and we can solve. Again, I see that we have a quadratic, so we need to get 0 on one side. I'm going to subtract 1 and add sine squared theta over to the other side. And get 0 here on the left. On the other side, I have 1 minus 1, so those subtract out. And then I have sine squared theta minus sine theta. And so now to solve, we're going to factor. Sine theta times sine theta minus 1. Set them both equal to 0. Sine theta equals 0. Sine is the y-coordinate, so it's going to be equal to 0 on the x-axis. I want answers between 0 degrees and 360 degrees, so that means theta is going to be equal to 0 degrees and 180 degrees. And over here, I'm going to add 1 to the other side. Sine theta equals 1. And between 0 and 360, that only happens one time at 90 degrees.